Alright, so we're still factorising over C, so with the complex numbers, over higher polynomials. So this is a cubic you can see here. So this is our second one here. Now an important little bit of information before we start. If f of a equals 0, then z minus a is a factor. So what does that mean for us? Well, if I can sub in a value for z and have this function, z cubed plus 4z squared plus 16z plus 10 equals 0, then z minus whatever that number was is a factor. So, unfortunately, we've got to do some trial and error here. So we've got to look at f of z equals z cubed plus 7z squared plus 16z plus 10 and stick in some number so that so that f of a equals 0. So I'm going to try it with the number 2. Okay, so f of 2 equals okay, so if I look at this, it's going to be 2 cubed, that's 8, minus 7 this, but let's put it into a calculator, see what happens. Alright, it's equal to 22, and that's no good. So the number 2 is out. Alright, let's trial and error again. Let's try 1. Maybe 1 because it's a smaller number, maybe I'll get 0 that way. So 1 cubed minus 7. Okay, stick that in my calculator. Alright, that's given me a number of 20. That's barely moved the needle. If I put in 0, what would I get? 0, 0, 0, I'd get 10. So 0 would get 10. 2 gets 22, 1 gets 20, 0 gets 10. What about negative 1? Put it in your calculator. 0. Alright, so trial and error. That means that f of negative 1 equals 0. If f of a equals 0, then z minus a is a factor. So now we know that a factor of this equation is z minus minus 1. So that means that z plus 1 is a factor. Alright, let's keep going. Now if z plus 1 is a factor, that means that f of z is going to be equal to z plus 1, and then it's a cubic, right? And I've taken a factor out. So the factor, and that's a linear factor, so the factor here is going to be quadratic. A quadratic times a linear factor is going to be a cubic. So now that factor is going to be z squared plus, let's see, pz plus q. I know it's just z squared because z squared times z is going to be z cubed. And then I need to know what the p value is here, and I need to know what the q value is here. So now what I can do is equate what it started out as with what it has now become. So I can say that z cubed plus 7z squared plus 16z plus 10 is equal to, and if I expand these brackets, I'll get z cubed pz squared, so this times this plus qz, then this times this plus z squared, then this times this pz, and then this times this plus q. Alright, so z cubed plus 7z squared plus 16z plus 10 equals z cubed plus pz squared plus qz plus z squared plus pz plus q. Therefore, q is equal to 10. Because q is the only constant here, and 10 is here. So now I know that q is equal to 10. So I can stick 10 wherever I see q in this current equation. So now I've got z cubed plus pz squared plus 10z plus z squared plus pz plus 10. And I know that that is equal to this. So let's take a look at what we've got now. We've got a z cubed on this side and a z cubed on this side. We've got a 10 here and a 10 here. So what have I got left if I kind of cancel them, disregard them? Well, what I can say now is that 7z squared, 7z squared plus 16z is equal to pz squared plus 10z plus z squared plus pz. Now we need to take a look at this. 7z squared. 7z squared. Well, the z squared terms here are here and here. So we can now say that 7z squared is equal to pz squared plus z squared. That must mean that p is equal to 6. Therefore, p is equal to 6. So now I know what q is, and now I know what p is. I can rewrite my equation now. So now I know that f of z is equal to z plus 1, z plus 1, bracket, z squared plus 6z plus 10. Alright, looking pretty good here. Now we need to factorize this. Now I'm not going to go through the process of factorizing that, but you should be able to factorize that. Factorize it by completing the square. So when you complete the square on this side, what you're going to end up with is z plus 3 squared plus 1. And all of that's in brackets. So z squared plus 6z plus 10 is the same as z plus 3 squared plus 1. Now, once we've done that, we can start looking for our complex number component. We can say that this is z plus 1, that can stay there, and then we can say that multiplied by z plus 3 squared minus I squared. And finally, we have z plus 1. This is going to be a difference of two squares, so it's going to end up being z plus 3 plus I, z plus 3 minus I. Alright, we're all factorized here, that's the end of the game. So, a couple of things here. You see it, it's a cubic or something like that. If you know this rule, you can do a little bit of trial and error to find out that the factor here was z plus 1. Once you know that it's z plus 1, you can rewrite it as z plus 1 bracket times a quadratic. And then you spend a little bit of time equating both sides, and then you finish off by factorizing. So, lots to do in a question like that, but it is a little bit procedural there.